All right, let's talk about a tool that absolutely changed the game for software developers, Docker. It's become the standard for how we package and run applications. And in the next few minutes, we're going to break down exactly what it is and why it's such a big deal.
Okay, if you've ever been anywhere near software development, you have definitely heard this phrase. It's that classic, super frustrating problem where code runs perfectly on one developer's laptop, but the second you move it somewhere else, it just breaks. Why? Well, it's because the environments are different. You got different operating systems, different software versions, you name it. It's a total configuration nightmare. And this, right here, is the exact problem Docker was built to solve.
So, to really get why Docker's solution is so brilliant, we first need to take a quick look at the old way of handling this problem. Then we'll see how containers offer a radically better way to do things.
The traditional solution was something called a virtual machine, or a VM. Now, a VM is pretty much a full computer simulated inside your computer. It's got its own entire operating system, and yeah, that gives you amazing isolation, but wow, it comes at a huge cost. As you can see here, VMs are heavyweight, we're talking gigabytes in size, and they just eat up your computer's resources. Containers, though, they're completely different. Instead of pretending to be a whole computer, they cleverly share the main operating system of the machine they're on. And that one simple difference makes them incredibly lightweight and ridiculously fast.
And this brings us right to the core idea, the container. Think of it as this perfect, standardized little box that bundles up your application's code with everything it needs to run. All the libraries, all the tools, the whole shebang. This single, self-contained unit can be moved from a developer's laptop to a test server to the cloud, and guess what? It runs exactly the same way every single time. That whole "it works on my machine" problem, poof, gone.
So how does Docker actually pull off this magic? Well, it uses a few key building blocks that work together perfectly. Let's take a look at the secret ingredients.
Everything in the Docker world starts with an image. An image is basically a template, a blueprint, or, and this is my favorite analogy, it's a recipe. It's this read-only file that contains all the instructions for creating a container, all your code, the runtime, and any libraries or dependencies you need.
So if the image is the recipe, then the container is the actual cake you baked from it. A container is a runnable, live instance of an image. It's the thing you can actually start, stop, and delete. It's this live, running, sandbox little world that holds your application, totally isolated from everything else.
Okay, so how do you create that recipe, the image? You write a Docker file. And honestly, it's just a simple text file with a list of step-by-step commands. You just tell Docker, hey, start from this operating system, copy my app files in, install these things I need, and here's the command to run when you start up. It's simple, it's repeatable, and it basically documents itself.
This diagram shows exactly how it all plugs together. See, Docker uses what's called a client-server architecture. On the left, you've got the client. That's you typing commands into your terminal. When you type something like Docker build, the client zips that command over to the Docker daemon, which is this background service that does all the heavy lifting. The daemon is what actually builds your images, runs your containers, and manages everything. And you can see on the right, it can pull pre-built images from a registry like Docker Hub or push your own images up there to share with others.
Now let's see how all these pieces fit into a really powerful everyday workflow. It's this simple, repeatable cycle that makes building and shipping software so much more efficient.
The whole workflow really just boils down to 4 key steps. It's super straightforward. First, you write your Docker file, defining your app's environment. Second, you use the Docker build command to create an image from that file. Third, you use Docker run to launch a container from your new image and test it out. And finally, once it's all good, you can push that image to a registry like Docker Hub, so you can share it with your team or deploy it.
And here's that same cycle just visualized. You start with the Docker file, right? The build command turns that into an image. The run command then launches a container from that very image. And if you want to share your masterpiece, you push the image to a registry. From there, anyone on your team can just pull it down and run an absolutely identical container on their own machine. It's just a clean, elegant loop.
Now, this whole workflow is perfect for a single application. But let's be real, modern apps are rarely that simple, right? They're usually made up of multiple different services that all need to work together. Exactly. What happens when your web application needs a database or a caching service? You don't want to cram all of those into one giant container. The best way to do it is to give each service its own separate container. But that brings up a new question. How in the world did they talk to each other?
And the answer is Docker networking. It's brilliant. Docker lets you create these custom, isolated virtual networks. You can then attach multiple containers to the same network, and they can all communicate with each other securely while staying completely isolated from any containers on other networks.
And this, right here, is where the real magic happens. On one of these special networks, Docker gives you automatic service discovery. This means containers can find each other just by using their name. So your web app container can connect to your database container just by using the name database. It never has to know its IP address. This is a huge deal. It makes building these complex apps from lots of little services not just possible, but actually straightforward and super reliable.
So there you have it. By creating this standardized unit, this shipping container for code, Docker completely solved the "it works on my machine" problem and just revolutionized how we build, ship, and run our applications. It means we get faster development, easier scaling, and way more reliable deployments. It made the whole process predictable and repeatable for everyone. The only question left is, what are you going to build and ship next?